Exercise 7.2 integrals. We have completed 18 questions. So first we will find the integral of the 20th one and then we will find the integral of 19th one. We have to find the integral of e power 2x minus e to the power minus 2x divided by e to the power 2x plus e to the power minus 2x with respect to x. There is some pattern here, right? 2x minus 2x, 2x and minus 2x, e to the power 2x, e to the power minus 2x, e to the power 2x and e to the power minus 2x. So I have written the pattern here. So e to the power value minus some function minus e to the power negative of that, then e to the power function plus e to the power negative of the function, and the function here is 2x. So when you have the integrand in this form, then it is very easy to do the substitution method. If the question is not in this form, then you have to bring it in this pattern that we will see in the question number 19. Okay, now let us apply the substitution method. Now which one we must select as t, whether numerator must be equated to t or denominator. So first let us write denominator equal to t equal to t. So now the denominator is in the form of t, right? The entire denominator is equal to t. Now we will differentiate with respect to x. So if you differentiate e to the power 2x, you will get 2 into e to the power 2x, and if you differentiate e to the power minus 2x, we will get minus 2 e to the power minus 2x, and this will be dt by dx. So let us take 2 common, e to the power 2x minus e to the power minus 2x. Let us cross multiply, dx is equal to dt. Now e to the power 2x minus e to the power minus 2x dx is equal to dt divided by 2. Now this is nothing but the numerator, right? Now the entire numerator can be written in the form of dt by 2, right? So this dt will be in the numerator. So what if you select the numerator equal to t, then the dt will come in the bottom. This dt by 2 will come in the bottom. So in order to avoid that, we will take the denominator equal to t and write the numerator in the form of dt. So now this implies integral of, so in the numerator it is dt divided by 2t. Now this implies, let us take 1 by 2 outside, which is constant, and 1 by t with respect to t. Now what is the integral of log modulus of t plus c? Now this implies 1 by 2 log of modulus of e to the power 2x plus e to the power minus 2x plus constant of integration. Now this implies 1 by 2 to log of, so e to the power 2x and e to the power minus 2x both are positive, so we can write it as e to the power 2x plus e to the power minus 2x plus c. So we write this modulus sign to filter out the negative. So already if the function here, the range of the function is positive, so we can avoid writing that modulus sign. So therefore integral of e to the power 2x minus e to the power minus 2x divided by e to the power 2x plus e to the power minus 2x with respect to x is equal to 1 by 2 log of e to the power 2x plus e to the power minus 2x plus constant of integration. So now we will solve the 19th one. So we have to find the integral of e to the power 2x minus 1 divided by e to the power 2x plus 1 with respect to x. So this question is partly similar to the 20th one, right? So here we have e to the power 2x, but here we have 1, and here we have e to the power 2x and here 1. So what we need to do is, we need to bring in this form, e to the power value, a function, then minus of e to the power negative of that, then again e to the power, the same thing here, the same function, then here negative of that. So if we bring in this form, then it is very easy to do the integration by substitution method. So how to change this 1? So we want e to the power negative of the value in the numerator and in the denominator, right? So for that, let us divide e to the power x in both numerator and denominator. Integral of e to the power 2x minus 1 divided by e to the power x, and in the denominator we have another fraction, e to the power 2x plus 1 divided by e to the power x. Now how to simplify this? So this is in the form of a minus b by c, which is a by c minus b by c. Then again in the denominator it is a plus b by c, which can be written as a by c plus b by c. So our main idea is to change this 1 here, right, in both numerator and denominator, and introduce exponential function. So now this implies integral of e to the power 2x divided by e to the power x, then minus 1 divided by e to the power x, and in the denominator e to the power 2x divided by e to the power x plus 1 divided by e to the power x. Now this is in the form of a power m by a power n, same base, right, e and e. So here when you have the same base, we will write it as a to the power m minus n. And how do we simplify this? So when we have 1 by a power m, we will write it as a to the power minus m. Now this implies integral of e to the power 2x minus x, then minus of e to the power minus x divided by e to the power 2x minus x plus e to the power minus x dx. This implies integral of e to the power x minus e to the power minus x. So here we have plus x minus x divided by again e to the power x plus e to the power minus x with respect to x. So we got that pattern. So let e power x plus e to the power minus x is equal to t. We will differentiate with respect to x. So if we differentiate e power x, we will get e power x. If we differentiate e to the power minus x, we will get e to the power minus x, and this is dt by dx. Now let us cross multiply e to the power x minus e to the power minus x dx is equal to dt. So how we can rewrite the function? So the numerator will be dt and the denominator will be, so this entire thing we wrote it as dt, and what we have to write in the denominator t. Now this implies integral of 1 by t with respect to t. So what is the formula? By inspection method we can write log of modulus of t plus c. So this implies what we have to write for t, it is e power x plus e to the power x plus c. So this, we are writing modulus sign, we can again avoid it because both e power x and e power minus x, the range is positive. Okay, so therefore what is the final step here? Integral of e to the power 2x minus 1 divided by e to the power 2x plus 1 with respect to x is log of e to the power x plus e to the power minus x plus c. So this is the required integral. So can you tell the integral of e power ax minus e power minus ax by e power ax plus e power minus ax dx without solving? So you have solved 19 and 20 of the same type, right? So even without solving you can tell the answer here. So the answer will be 1 by, so what is the coefficient of x here? A, right? So 1 by a log of, what we have to write? We have to write the denominator, that is e to the power ax plus e to the power minus ax plus c. So tell me in the comment section, did you answer this